I also start with a brief recap of what we presented almost exactly a year ago and where we were there. And what we presented last time was the pipeline, how we got from input data from the three collections that we use so far, different types of formats, to our final research platform. A lot of cleaning and alignment has to be done. So we align all the entities with external reference data, mainly GND and Wikidata. We do image preparation. The images themselves live, for example, in Wikidata for the National Library images, on ERARA for the Central Library images, and they're already accessible through a IIIF endpoint. And we also made our own IIIF server for images which are not yet online. And actually also for the images on Wikidata, because the IIIF endpoint has not yet materialized in production. Then we also developed some pre-processing pipelines where we basically pre-process the input data, put it together with the curated aligned data, do some processing on kind of date fields, for example, and other non-machine readable full text fields. Then we convert everything to CDOC-CRM through a mapping done in X3ML. We add some external reference data through an identifier. So for example, we get the coordinates for the places that we align the Wikidata as well as the images. And we ingest everything into a research platform. That's what we presented so far. So what have we doing since then? Actually quite a lot of very tedious data cleaning and modeling and improvements and things I will not bore you with. So I instead just focus on these four topics in terms of what we enhanced, we did in terms of platform enhancements, how we worked on making the platform fast and usable, what we did with the images themselves, and last but not least, what we've been busy with the last few months, the integration with Snapshot, the georeferencing platform. So one thing we focused a bit on is just the kind of user experience and how we display the data on the research platform. Now, this is meant as a platform for art historical research, so for professional researchers, but we wanted to make it also accessible for the general public. And so therefore we gave quite some thoughts on how to display this data. And as you might know, the graph data can be quite complex. So we wanted to narrow this onto a more readable projection, but without losing some of the detail that we find. So for example, in terms of the persons that are associated with the events, we didn't translate them back to terms like author or editor, but we show kind of the attached persons along with their roles and along with their events that they take place. So in a similar way, we kind of reflect the graph structure on the display of the records. And this has also a bit to do with the limitations we encountered in the field visualizations. So we also kind of show the raw fields further down, but we found that with more complex fields, for example, the roles that certain persons have carried out in the production of an image, it just results in quite complex fields, which then again can result in quite high loading times. And we didn't really want to materialize those fields because they also changed. So that also was a reason why we kind of had something a bit more handcrafted than just the field visualizations. It's another example of a complex field with the dimensions, because we have dimensions of different parts of the images in different units and different terminologies. So this was just kind of also to simplify this from a user perspective while retaining the detail and complexity underneath. In terms of data input, we also worked with part project 2 on how we actually want to model this, and we have different roles and terms that we would want to add data to, for example, about the printing, about the engraving, about the coloring, and all these activities relate to different creation processes. So the sketching basically relates to the conceptual image that is being represented, while, for example, the coloring modifies something which is already printed. And again, this is something we wanted to do in a way that the user does not need to be knowledgeable of or even see this model. So that's why we integrated this thesaurus that's definitely presented, which is directly derived from the terms that are used to describe the images on the prints. And we added relations to the events that they refer to. So for example, the concept of the engraver relates to the production event, etc. And so based on this thesaurus, you can add contributors by selecting either from the list of terms or also by searching for the Latin abbreviation. You can select the term, and it automatically selects the correct context or correct location in the graph where to add these statements. So you can just add the person and you don't need to take care of the data model underneath. So this is the data that is being created. So we say it's a proposition set that is about a sub-production, so the production part of this image, which was carried out by an engraver. And the engraver in this case is our BSO thesaurus term. And what we also added, while we added kind of lots of data input, is a backup. So not only kind of backup of the entire server, but backup of the individual named graphs that is being written onto separate Git repository, which means we also have a certain level of version control, so we can roll back the changes that people made. And I include links, I will share this presentation later on, to the individual repositories and files where you can find these things. In terms of performance optimization, we encountered, of course, that the more we add to the platform, the more complex field definitions we integrate, it slows down a bit. So what we then did, and is also we took some approaches from what we did with the GTA platform, where we also had to identify some bottlenecks. We added between the research platform and the BlazeGraph triple store a proxy, which basically just records every request that is being passed through it. And then we added a Jupyter notebook, which reads these logs and extracts all the Sparkle queries and then executes them again against the BlazeGraph endpoint, this time measuring the time it takes to execute each query. So this means that we were able to identify the queries which took longer and optimize those, and most of them actually refer to the descriptions and thumbnail queries. So what we did, we optimized those queries, but also we cached the external thumbnails, all the images that come from Wikidata. We are now caching locally, so those don't need to make a round trip from Wikidata to us. And again, I include the script. It's obviously a bit purpose-built, but maybe useful also for other things. Image processing. So one important task we had was image segmentation, so that a lot of these images have with them additional artifacts, so that this can be, background, obviously the paper is printed on, but also these calibration artifacts that we see here. And for both for visual reasons, for presenting them, we want to get rid of this, or not get rid of it, but at least know where it is. But also for some other image tasks, we want to be able to then separate the image from the rest, so that we actually can deal just with the image. So what we first did was using a DH segment library developed at the EPFL Lausanne, and we retrained their model based on our own data. So we labeled the data actually in Runway, retrained it, and then ran the model on our own images, and the results were quite good. So these are all good examples of where it recognized the image. But we also had quite a few where it was just quite wrong. And that's not unusual, but the problem was that it was wrong in ways that were not really transparent to us. So it was quite hard to separate the good from the bad. And we tried, annotating more, retraining more, but by the end, it's always a bit of a trial and error with this kind of brute force machine learning approach. So we basically redid it from scratch using more classical AI, using OpenCV. And this works with outline detection. So basically we just convert it to a tone image. We detect the outlines, and then we have some kind of heuristics to select the correct image. So in this case, we get these two outlines, and then we select sometimes the bigger one, sometimes also the squarest one, because we know that this color bar has a certain shape. And the same with images that don't have a color bar. In these cases, it also just crops to the image. So here we had also good results, I would say, about the same quality. But most importantly, when it was wrong, it was mostly wrong in predictable ways. So it would, for example, recognize this color bar instead of the image. And we could query the database for images or image segment that only cover a small region or that have a certain weird size. And it was quite easy to already eliminate quite a few wrong image detections. And the ones we still find, we can correct manually in the platform. Another thing we implemented is image similarity, or rather duplicate detection. There basically we used the PASTEC library, which Lucas Klick has already used for the what's it called, the art research platform, and we just put kind of similarity measures for each image in the database, and this already allowed us to identify images that appear in more than one collection. So here from the Nationalbibliothek and from the central library, and very often, as you see here in this example, we have different versions of an image. So one black and white, one colored. So we can also look at different stages of an image. Not quite image processing, but we also included similarities based on title. And here we used a Stuttgart index to also display images that bear a similarity based on their title. And this also is quite insightful to discover similar images where the metadata or the images themselves don't offer enough clues. Finally, the biggest tasks of the last month's snapshot integration. So here we kind of went in different levels. So I would say level 0 was what we already prepared, I think a year ago, initial set of images for georeferencing on the platform. Of course, we don't only have landscape images. So what we did there is to train an image classifier on images that contain landscapes and images that contain something else. So this created our initial set of images that we then send to Snapshot as then just a CSV export and links to the FFF images. And up to now, there are about 15% already georeferenced. So this was kind of our initial step. What I would say level 1 was then the display of snapshot views within BSO platform. And here Snapshot offers an iframe viewer that can be embedded, and important for us, that can be embedded based on our internal identifiers, because at this stage we didn't know the snapshot identifiers. So we made a little custom component for the platform that allows us to embed the snapshot view based on our URIs. The next level was then to retrieve the geolocation data from Snapshot platform. And Snapshot itself offers a REST API. And what we did was to add a separate service, which every day or so retrieves the data from the Snapshot API JSON format, and then converts it to XML so that it can be mapped using the XML engine to CDOC CRM. And then it ingests it to our platform via the Graph Store API. So this means that this service is independent from the entire other pipeline, and it just needs the authentication to add data to the Snapshot graph. So initially this was just for the images, so for the geolocation for the images. And by now we also have observations. So these are comments that user can add, but also annotations on images that user add through the Snapshot platform. And we convert those also to region annotations in our platform, which means we can then again display and edit them in our platform. Level 3, our final level, what we wanted to do was to be able to send new images to Snapshot. So as I said, we made an initial selection, but there are of course more landscape images that we also now want to georeference, and we want to be able to send them to the Snapshot platform. And Snapshot integrated or extended their REST API to support this, to submit images via post, as long as they're already on FFF. It's both for technical but also for legal reasons, because they don't want to upload just any image. But our platform, because we use the MetaFacts open source platform, we can only communicate through Sparkle with external services. So that's the, I think Research Space implements a translator as well as the commercial MetaFacts platform. But because we wanted to use the open source one, we had to implement kind of a fake Sparkle endpoint that can translate between between the Sparkle API and the REST API. So this is basically what we did here as a separate service. So this can also be reused, and we are using it also in another component of the project. But this basically now means we can send images to Snapshot, and also we can edit images that we've already sent, which is quite crucial, because by now we have also the image regions that we didn't have in the beginning, and Snapshot also preparations that we can update the kind of region of the images for images that are already georeferenced. Okay, so I'm just going to show you some of the things I've talked about. So this is the platform as it looks at the moment. Can demonstrate the loading time. As you see, it's really quick, not only because I just loaded it before. So this is the view for the individual images. The ability to add data, I quickly have to switch to the staging version because this is still in development. But just to show you how we implemented this, I think I need to log in again. So this is the place where we add data. This is what I demonstrated the contributors. We also have the ability to add things that are depicted or just external, kind of same as links. And here, this is our thesaurus. And for example, if I want to add an engraver, I can add an engraver here, save it, and this now gives me here the custom data. And I can also go back and edit it. When we edit it, we're taken directly to the form about production. And we can add here, for example, also more types based on the thesaurus that we just implemented. Okay. I have similar entities. So in this case, we have both by title and visually. So there is another Reutigen, and you see there is also Frutigen. So it picked up the Tigen, which in this case is maybe not really relevant, but just give you an impression of how the similarity works. We have visual similarity, and you see here indeed we have two other versions of this image, black and white version in the collection of the National Library, and also a colored version in the National Library collection. So then I maybe briefly show the snapshot integration. So you see that we have already the geolocated images here. And this is updated daily, but obviously only after we confirm the images on the platform. So there is a kind of a quality assurance stage where we have to confirm that the image is actually correct. And so once it's correct, then it will be ingested into the platform. So as you can see here, for example, this is a good example. So here is one of these cases where we have some artifacts that are not visible, but still we would like to get rid of it because it also affects how we calculate the viewpoint, because we calculate like how much of the landscape is depicted, and for this obviously we need to have the correct borders of the image. So here you see also that we included already the snapshot reference data. But what I want to do here is to edit the region that I'm sending to snapshot. And with this region, I'm already quite happy. If not, I can go in there and edit it, or add a different one if I want, but I just leave this as it is. And I say select, and then it's just another confirmation step to update it. And then now you see we have the image in the snapshot view without the additional artifacts. And this is actually quite a good match. So yeah, doesn't seem to be a Photoshop. Okay. All right, last but not least, I also show you how we add new images to the platform. For this, I just integrated a filter for images that are not yet on snapshot. And I take the Fehlmann collection because this one was not yet available when we delivered the first set to snapshot. Let's just find one which is actually landscape. Yeah, this is maybe a good one. So again, you have the ability here, submit to snapshot. And it asked me for the region. In this case, I make a little adjustment. So there's a bit less here and a bit more here. Okay, so this is updated. I select it. There we go. It's always when you demonstrate something. Okay, I'm sorry. Never works. Well, what it's doing here, it's trying to query the snapshot database for what they call photographers, because we submit the images, but we also submit all the persons that are associated with it. So it uses service query to our fake snapshot API and queries for the photographer ID based on the link. So let's see. Yeah, it looks like my service is not running. So you see, this is really cutting edge what we're doing here.